गुड मॉर्निंग। कैसे हैं आप? आई होप यू ऑल आर डूइंग वेल। टुडे is our 21st lecture, and in this lecture we will talk about the sequence control of AC voltage controller, and of course we will take the another controller which is integral cycle control. That too we will see in today's talk. Right? So let us start. First of all, that question come in the mind, why sequence control is required. This sequence control or multi-stage control is required to improve the system power factor and to improve the harmonic content of input current as well as the harmonics of the output voltage, right? So to improve all these, we use sequence control. Now exactly what the meaning of sequence control? Sequence control means where we use two or more than two voltage controller simultaneously, then we will call it sequence control. Let us understand this with a diagram. It is something like this. You can see we have, this is the N stage sequence AC voltage controller. You can see there are N voltage controller, single phase AC voltage controller are connected. There is one transformer which is having one primary and N secondaries, and this the voltage of each secondary is Vs by N. Suppose this is Vs, so it is Vs by N, means the voltage of each one, this Vs by N is Vm sine omega t divided by N, where N is the number of AC voltage controller or N stage sequence control it is, and this Vs is equal to Vm sine of omega t. All these things are very elementary and I hope you understood this. Now these controller are control in step, means for controlling voltage up to this Vs by N, only one controller need to be operated and remaining N minus 1 controller are not triggered, means the gate pulses are not given to these. Only this is to be controlled to control the voltage between 0 less than V output less than Vs by N, right? So for this only one controller is being used, right? Now for this I have already told you, these are used to improve the system power factor as well as improve the harmonic TSD, harmonic in input current and the output voltage. Now let us understand the thing with two-stage sequence controller. As I said, for N stage there are N controllers. So this is the two stage. So there are two AC controller. Each voltage V1 and V2 both are equal and equal to Vm sine omega t. That means this voltage is 2 Vm sine of omega t. Half voltage is here and half voltage is here. Now, if we wish to control, let us see it for resistive load. First, we will see it for resistive load, then we will see for RL type load, right? So, let us see if, let me zoom it. Now, it's absolutely fine. If we wish to control it for only voltage up to Vm sine omega t, then what we will do, we will simply control for this voltage, we will simply control for this voltage, and no trigger pulse is given to T1 and T2. They are permanently off. They are permanently off for voltage control between 0 to V2, that is 0 to Vm sine omega t. So it is as good as we are using in the single phase AC controller, since we are using it to see the performance in the two stage. That means we want to control the voltage from 50% to 100%. So for that, this controller, this T3, T4 must be on at 0 degree. These T3, T4 must be on at 0 degree, right? And T1, T2 needs to be triggered to control the voltage from V output is greater than V2 less than V1 plus V2. So all the time minimum voltage is V2, that means T3, T4 must be on. Now you trigger the T1 at an angle alpha. The moment you trigger, as the load is resistive, the voltage is reach up to this and it will follow the curve V1 plus V2. At the same time, current will jump from this Vm by R to 2 Vm by R and it will follow the curve 2 Vm sin omega t. So it would be like this. One thing you should notice, although this T3 is in forward bias for the same time for which T1 is in forward bias. But the moment T1 is triggered, it will make this T3 is in reverse bias. This will make the T3 in reverse bias. So it will not conduct and current will jump from here to here and this voltage will start to come. At this point, omega t equal to pi, since the load is resistive, T3 automatically get turned off and you trigger T4 at 0 angle, so it will follow the negative path of this V2 curve up to this point and you trigger T2, so current will jump in negative direction to this curve, that is 2 Vm sin omega t, or you can say V1 plus V2 curve, the same this curve, this curve, right? And current will also jump from Vm by R, of course negative Vm by R to negative 2 Vm by R, and cycle goes on. Now let us see the waveform for RL load. Let us see the waveform for RL load. See, the power electronics is the game of switching. How you trigger the device, that will give you the desired output, right? So as I said, let me also mark this. Let me check. I have already marked after this, so I am not going to show you now. अभी देखते हैं हम लोग हैं आगे, हम लोगों ने नोट्स के फॉर्म में उसको लिख रखा है, तो परेशान होने की जरूरत नहीं है. मैं हिंदी में भी समझा दे रहा हूं क्योंकि बहुत से बच्चे फिर शिकायत करते हैं. बहुत सिंपल सी बच्चा पार्टी इसमें बात है कि T3 और T4 को हम लोग 0 डिग्री पे ऑन करके रखेंगे. जब भी कभी 0 से V तक का कंट्रोल चाहिए होगा, V2 तक का, तो T3 T4 से काम चलाएंगे और T1 T2 को कभी भी ऑन नहीं करेंगे. जब हमको कंट्रोल V2 से लेकर के V1 प्लस V2 का चाहिए होगा तो T3 T4 हमेशा ऑन रहेंगे 0 डिग्री पे, और हम लोग वोल्टेज कंट्रोल करेंगे T1 और T2 को अल्फा डिग्री पे ट्रिगर करके. क्लियर? सो नाउ लेट अस टेक द एग्जांपल ऑफ RL लोड. सी योर दिस T3 T4, these are triggered at 0, so let us say this voltage is coming. Now you trigger the device T1. The moment you trigger, voltage will jump from V2 to V1 plus V2 and follow this curve. At this point, the load current is not 0, so it will continue to conduct. The moment it will continue to conduct, that means T1 is conducting, so whatsoever the input voltage, that will come. That means twice V1 plus V2, V1 plus V2, that is 2 Vm sin omega t, that curve need to be followed. And after that, the current flowing through T1 is 0, and you have triggered the T4. So because it is already triggered at 0 degree, so the current will follow in negative direction and keeps on increasing like exponential current. Hmm? And the voltage is follow the V2 curve, right? V2 curve. And again you trigger the device T2 at an angle alpha, so voltage will immediately jump to V1 plus V2 curve, and current is start increasing. Here you can see it is like this. So slope and everything is get changed. And same up to 2 pi, the current is not zero. So T2 keep on conducting. When T2 is keep on conducting, the V1 plus V2 voltage curve is follow. Unless until the current flowing through T2 is not zero. So the same cycle is repeated here. This same cycle is repeated here. And the device conduction I have already shown. Whenever the T1 current is zero, no, sorry, whenever T1 current is zero, it will go T4, then T2, then after that T3, then T1, like this, T3 and then T1. And prior to this, T2 was coming. T2 was coming. That means T2 was conducting. So you can make the note that for controlling 0 to VRMS, only T3, T4 are to be controlled. T1, T2 are always turned off. Here one thing you should clear, this Vs is equal to twice Vrms sine of omega t. So that half of Vrms here and half Vrms here. Here. It is like this. And T1, T2 off. And for controlling Vrms to 2 Vrms, we trigger T1, T2 for angle alpha and T3, T4 just give me a second. Here a small correction for Vrms to 2 Vrms, firing angle alpha for not for T3, T4, alpha for, let me take the red color pen. T1, T2. Okay, fine. Here it is written like this. T3, T4. Firing angle alpha for T3, T4. Fine. Firing angle alpha for T3, T4. Firing angle alpha for T3, T4 are kept 0, and firing angle alpha for thyristor T1, T2 are varied from 0 to 180 degrees. Right? This needs to be very clear. This is the case. Now the second article which we should study, that is the integral cycle control. See, what we are doing till now, to control the output voltage, we are changing the firing angle alpha, right? So when we change the firing angle, output voltage get changed, right? But if think about when the mechanical time constant or heating time constant for resistive type of load is quite high, do you think there will be a substantial change can be measured by simply changing this firing angle? No. So for that, I mean, where the mechanical time constant or heating time constant is quite high, we use integral cycle control. सरल भाषा में अगर कहें तो जैसे आपके घर का गीजर, इसमें देखिए आप थोड़ी देर को ऑन हो जाता है, जब आपका टेम्परेचर रीच हो जाता है तो ये ऑफ हो जाता है. तो ये किस तरीके से कंट्रोल कर रहा है? ये कुछ देर को सप्लाई दे रहा है और कुछ देर को सप्लाई घटा ले रहा है. तो द सेम टाइप ऑफ कंट्रोल इज यूज like for spa, where we have to maintain the temperature of steam at a particular level. There we use integral cycle control, right? Means these are used where the drive constant, the electrical motor drive constant is quite high. There we use AC voltage integral cycle control, right? Or where we need to control the temperature and time constant of thermal time constant is quite high. There we use this integral cycle control. Now what exactly the integral cycle control is? इंटीग्रल साइकिल कंट्रोल मीन्स कुछ देर को हमें ऑन करना है, कुछ देर को हमको ऑफ करना है. जैसे कि यहां पर आप देख सकते हैं सिंपल हमारा सर्किट है T1 और T2 एसी वोल्टेज कंट्रोलर में जैसे होते हैं वही सेम सर्किट है. ये हमारा सर्किट है. तो T1 को हमने यहां पर अगर आप देखें T1 और T2 मीन्स पॉजिटिव साइकिल में T1 और नेगेटिव साइकिल में T2. तो 0 डिग्री पे हमने इसको ऑन करके रखा है. कितनी साइकिल के लिए रखा है? 3 साइकिल के लिए हमने इसको ऑन करके रखा है, राइट? साइकिल 1, साइकिल 2 एंड साइकिल 3. 3 के लिए ऑन करके रखा और 2 के लिए ऑफ कर दिया. अर्थात इन जनरल वी आर सेइंग our AC voltage controller is on for n cycle and off for m cycle. So अगर टोटल पीरियड की बात करें तो इट इज इक्वल टू दिस पीरियड 2 पाई टाइम्स n प्लस m, क्योंकि n प्लस m साइकिल के बाद ही तो ये अपने आप को रिपीट कर रहा है. n साइकिल फिर से ऑन रह रहा है और फिर m साइकिल ऑफ रह रहा है. तो टोटल टाइम पीरियड इज 2 पाई टाइम्स n प्लस m, राइट? नाउ जस्ट see, this is our input supply, this is our input supply, and we turn on for 3 cycle and off for 2 cycle, right? This is 1 cycle, this is second, this is third, this is 1 off, 2 off, and then repeat. So we talk about the average RMS voltage of this. The RMS voltage is equal to 0 to 2 pi Vm sin omega t squared d omega t, and the period is 1 upon 2 pi n plus m. The period is 1 upon 2 pi n plus m, and out of this 2 pi times n plus m, how many cycle it is on? It is on for n. Now once you solve this, you will get it is come out to be Vrms times n upon n plus m. That n plus n m is called the duty cycle, right? This we can say it is the duty cycle. Duty cycle, right? And this Vrms is the supply Vrms, which is Vm by root 2. Vm by root 2. So V output is equal to Vrms times under root K, where K is the duty cycle. Now if we talk about the RMS current, it is simple. VORMS divided by VORMS is the output voltage. VORMS is the output voltage. मैं यहाँ let me write output RMS voltage VORMS. हाँ, थोड़ा सा और साफ सुथरा लिख देते हैं भाई, सो डैट आपको किसी तरीके की परेशानी ना हो. आउटपुट RMS voltage VRMS, right? VORMS, it is equal to this, and this is the supply voltage. I hope ये तो आपको clear होगा. This is the supply voltage RMS. Now power delivered to the load is simply VORMS by square by R. It is given by this, that is K times VRMS square by R. Now RMS input current IRMS is equal to IORMS. So input VA is equal to VRMS times IORMS. Just put this value, and the input power factor we know, power delivered to the load divided by input VA. just put this value, we will get the input power factor is come out to be VORMS upon VRMS, which was also coming in case of AC/DC rectifier, if you remember. So it is simple. After putting this value, we will get input power factor is come out to be under root K. Right? So these two are the control which are being used in AC voltage controller. One is the phase control, where we change the firing angle. Other one is the sequence control to improve the system power factor, input current harmonic and output voltage harmonic. And the last, that is the integral cycle control. In next lecture, we will start the three-phase AC regulator. But before going to that, let us check the average value of thyristor current. The average value of thyristor current is given by, how this come Vm sin omega t? It is simple, Vm sin omega t divided by R. So Vm by R is equal to Im. So it is equal to Im sin omega t, and the duration of flowing this current is 0 to pi. So it has come out to be like this. Means average current is come out to be K times Im upon pi. Here just see, average current means there are two thyristors. So current in T1 is flowing from 0 to pi. Similarly, current in T2 is flowing from pi to 2 pi. Although the period is 2 pi upon 2 pi times n plus m, and the on cycle is repeating for n times, right? कुल करंट, जो टोटल करंट बह रही बच्चा, वो T1 में बह रही है और आधी करंट T2 में बह रही है. तो टोटल टाइम पीरियड जो है हमारा n साइकिल ऑन है और m साइकिल ऑफ है. तो 2 पाई टाइम्स n प्लस m 1 अपॉन 2 पाई टाइम्स n प्लस m हुआ, जिसमें से n साइकिल को ये हमारा ऑन है. और जो करंट का ड्यूरेशन है वो 0 टू पाई लेंगे, 2 पाई नहीं, क्योंकि बाकी की आधी करंट तो दूसरे से बह रही. तो एक करंट की, एक थायरिस्टर की एवरेज करंट हम निकाल रहे हैं, अर्थात जो पीरियड होगा दैट विल बी 0 to 2 pi. It is come out to be K times Im upon pi. Similarly, we can calculate the RMS current. Again, mind it, the period is to be taken at 0 to pi because it is the current flowing through one thyristor, right? So it is come out to be Im under root K by 2. It is come out to be Im under root K by 2. Clear? Now with this, our all type of controller is completed. That is, either it could be sequence control, it could be integral cycle control. In next class, we will start the three-phase AC regulator. Right? Meanwhile, you keep on learning. In case of any problem, you can WhatsApp me at this number. And also, I suggest subscribe the channel and press the bell icon so that you can get the notify whenever I come in online. So bye bye. Keep on learning.